Hello students, welcome back to the third video of this playlist. So in this video we will be solving the third question from the most recent past paper of Pure Mathematics 3, which is October 2024 paper. So let's see what's the question number 3 from this paper is about. So basically the concepts behind this question is from modulus and graphs that has been discussed in the second chapter of your Pure Mathematics 3 textbook. So in order to be able to solve this question, definitely you have idea about the concepts that has been discussed in chapter number 2 of your Pure Mathematics 3 textbook. So let's get started with question number 3. So right at the beginning, you can see a figure, that is figure number 2, it's given. You can guess out that this is a quadratic graph, isn't it? Okay. So in this question, okay, figure 2 shows a sketch of the curve with equation y equals to f of x, where f of x equals to 2x squared negative 10x, where x element real numbers. This is a quadratic equation, a quadratic function f of x. Okay, fine. So part A is asking to solve the equation f of modulus x equals to 48. Okay, f of modulus x equals to 48. We need to solve this equation. So always remember, always keep in mind, when you are dealing with modulus functions or modulus graphs, okay, or solving inequalities related to modulus graphs or modulus functions, the sketch is very important thing. Okay, so as in here, for f of modulus x, right at the beginning you will consider the sketch. The sketch will let you know the approach. Okay, so f of modulus x, that means the modulus is within the bracket. So in that case, how the sketch would be, the work of the modulus is to make values positive. That means if you put any, whatever the value of x is, either positive or negative, it will give outcome what? Positive, due to the modulus. That means if you put negative x values here, the modulus will make it positive, right? So that means in the positive x-axis, the part of the graph is as it is, but in the negative x-axis, you will get the exact shape of that in positive x-axis, in the negative x-axis too, because due to the modulus, the positive x value, the negative x values are getting positive, and the function will be giving you the range for the positive x values even for the negative x input. Okay, so that means the curve will be exactly like this. Okay, symmetrical, exactly like this. Okay, so now they asked for f of modulus x equals to 48. So 48 is where? This is, as let's suppose this is 48, and this part will get erased. Which part will get erased? This part will now no longer be there, because modulus x, that's why this part will be not found. Okay, so all the negative x ranges will disappear. Okay, so you will have only 2 points of intersection. Okay, and both are equidistant from the origin. Okay, now let's go for the solution, part A. So modulus x, right? So 2 modulus x whole squared negative 10x equals to what? 48, right? So modulus x, if you take out the modulus, you will get two possible values, positive x, negative x, but since it is whole squared, so it will be always what? Positive. Okay, this is equals to what? 48. Now what we can do, divide both sides by 2 and take the 48 to the left, so you'll get x squared negative 5x negative 24 equals to what? 0. Now solve for x. This is a quadratic equation, So 3 times 8, this is what? 24, right? So x minus 8 times x plus 3 equals 0. So you will get the value for x is what? Okay, this was x squared, right? Okay, x squared. Okay, so you'll get either x equals to 8 or x equals to what? Negative 3. Fine. Okay, so we got one value positive 8, the other one is what? Negative 3. So which one would be the answer? Now you might ask, we were supposed to get two values only, right? And both were supposed to be equal, right? But we got two different values. One is positive, the other one is what? Negative. So you can see from the sketch, right, that 8 is the acceptable one, and negative 3 is what? Should be ignored. Okay, now you might ask why we got negative 3 actually. The reason is that since it is a modulus graph, so if you extend it towards this, okay, basically we're getting another point of intersection here, another point of intersection here. This is what? 3. Here x is 3, and here x is what? Negative 3. And here it is 8, here it is what? Negative 8. Make sense? So that's why we got two possible values. One is 8 and another one is what? Negative 3. Okay, so what we will write? We will write only 8 and negative 8, because at these 2 points the line y equals to 48 is intersecting the modulus function, the modulus graph. Okay, so the possible values for x are plus minus 8. That's it, and that's what exactly part A of question number 3 has asked for. Okay, next is part B. Part B is asking to find the set of values of x for which f of x whole modulus greater than or equal 5 over twice of x. Okay, so this is basically solving a modulus inequality. Okay, so what I said earlier, always for solving modulus inequality or equation, always consider the what? Sketch. F of x whole modulus now. Okay, so at first let me erase these stuffs from the sketch. Okay, so we need to sketch f of x what? Whole modulus, right? Okay, so f of x whole modulus, what does it mean? F of x whole modulus, that means it's modulus on the y values. That means there will be no negative y values you will find here. That means the curve f of x, it will have no part below the x-axis. The part that was below the x-axis, it will be now above the x-axis. Okay, so f of modulus x, f of x modulus whole modulus will be what? Its curve will be like this. Okay, because no part, no negative y values is possible now, all will become positive. That's why we will have f of x whole modulus graph is like this. Okay, done. Now we need to sketch the line which is 5 over twice of x. Now you will get super confused, like how do we consider 5 over twice of x? Though we know this is positive x coordinate, so will it pass through this, that, or how it will pass, right? Because there's so many possible ways to, like, it can also pass like this, isn't it? There's so many ways to draw the line, isn't it? So how can you figure this out? Have a look. So if you consider, okay, so we will consider this vertex. What's that vertex is? Okay, so to figure out that vertex, consider this equation, 2x squared negative 10x. This is what? Quadratic equation. So from the completing the square form, we can get the coordinates of the turning point, isn't it? So you don't need to simplify the whole quadratic equation to completing the square form. Just try to get the pattern. Okay, we will take 2 common, so you will get x squared negative 5x. Then in the completing the square form, x squared plus bx, so x plus b over 2 whole squared, and then something. Okay, so we got the x coordinate. X coordinate is what? 5 over 2. This x coordinate is 5/2. Now get the y coordinate by substituting this x value here. So use your calculator. 2 times 2.5 squared, negative 10 times 2.5, that would give you negative 25/2 for this point. But it is now modulus, right? So this negative y value will become positive, right? So that would give you 25/2. This is the what? Y value for the vertex. Now we need to figure out whether the line 5/2 of x it will pass through the vertex or not. Okay, so we will equate 5/2 of x equals to 25/2. So you will get x equals to 5. That means at x equals to 5, not x equals to 2.5, at x equals to 5 it will be passing through this y value. That means the line will be like this. Okay, the line will be like this. Okay, done. So now our work is to figure out the critical values. Okay, so let's figure out the critical values for part B. At critical points, what would be the case? F of x whole modulus, right? This will be equal to 5/2 of x. Okay, so the equation of f of x whole modulus is what? 2x squared negative 10x whole modulus. This is equals to 5/2 of x. So if you take out the modulus, you will get two possible values. One is positive, the other one is what? Negative. So either this is positive or what? Negative. 2x squared negative 10x equals to what? Negative 5/2 of x. Okay, now multiply both sides by 2. You will get 4x squared negative 20x equals to what? 5x. Or multiply both sides by 2, you will get what? 4x squared negative 20x. This is equals to what? 5 negative 5x, right? Okay, so now take all the terms on the same side. You will get 4x squared negative 25x equals to what? 0. Or what you will get here? 4x squared negative 20x plus 5x. This is negative 15x. That would be equals to 0. Now we can take x common. So 4x minus 25 equals 0. Or if you take x common, you will get 4x minus 15 equals 0. Okay, so we will get either x equals to 0 or x equals to what? X equals to 25/4 or what? X equals to 15/4. We got three critical points. Now see the sketch y. This is one point at the origin. This point is what? 15/4, the smaller one, and the greater one is basically for this intersection. This is what? 25/4. Okay, now see the inequality. The inequality wanted the x values such that the modulus curve will remain above the straight line. So which part of the modulus curve is above the straight line? This part is above, right? So this part can be found for which x values? For x values less than or equal what? 15/4, right? And again on the right side you can see these x values, sorry, this part is above the line. So this part can be found for which x values? This part can be found for x greater than or equal 25/4. That's it. Okay, so what we can say, the possible range of possible values for x is r. So x is less than or equal what? 15/4, or x is greater than or equal what? 25/4. That's exactly the what part B of question number 3 has asked for. That's it.